Hi, and welcome back to Interpreting the Summary. Let's start with some new vocabulary, shall we? The first new phrase is MLE, or maximum likelihood estimation. First, I'll explain the likelihood function on which it is based. It is a function which estimates how likely it is that the model at hand describes the real underlying relationship of the variables. In simple words, the bigger the likelihood function, the higher the probability that our model is correct. Without getting too much into the statistics of it, MLE tries to maximize the likelihood function. That's why it is called maximum likelihood estimation. Knowing this and the fact that iterations are in play, we should already have an idea what's going on behind the scenes. The computer is going through different values until it finds a model for which the likelihood is the highest. When it can no longer improve it, it will just stop the optimization. That is also how any typical machine learning process goes. Okay. The next new term is log likelihood. Now that you know what likelihood is, it is time to tell you that it is much more convenient to take the log likelihood when performing MLE. Because of this convenience, the log likelihood is the more popular metric. By the way, the value of the log likelihood is almost, but not always, negative, and the bigger it is, the better. Then we have LL null. It stands for log likelihood null. The LL null is the log likelihood of a model which has no independent variables. Actually, the same y is the dependent variable of that model, but the sole independent variable is an array of ones. This array is the constant we are adding with the addConstant method. Let me show you real quick. Here's an array of ones only. If we create a logistic regression based on it, it will have a log likelihood equal to the LL null of the previous model. So we were not lying. All right, but why? Well, you may want to compare the log likelihood of your model with the LL null to see if your model has any explanatory power. Does that sound familiar? Seeing if our model is significant. There was this F test for the linear regression. There must be one for logistic regression too. Good news, there is. It is called a log likelihood ratio test, or LLR. It is based on the log likelihood of the model and the LL null. It measures if our model is statistically different from the LL null, aka a useless model. Without telling you the exact way to perform it, we have its p-value, and that's all we need. As we can see, it is very low, around 0.000. Our model is significant. Finally, let's talk about the pseudo R-squared. Unlike the linear one, there is no such thing as a clearly defined R-squared for the logistic regression. There are several propositions which have a similar meaning to the R-squared, but none of them is even close to the real deal. Some terms you may have heard are AIC, BIC, and McFadden's R-squared. Well, this one here is McFadden's R-squared. According to McFadden himself, a good pseudo R-squared is somewhere between 0.2 and 0.4. Moreover, this measure is mostly useful for comparing variations of the same model. Different models will have completely different and incomparable pseudo R-squares. All right. We've gone through the whole table. What we have left is a coefficients table which we can read perfectly. Unfortunately, we can't understand it perfectly just yet. When will we? In less than 5 minutes. Just jump to the next lesson. Thanks for watching.